You've got to be getting on to your Criterion C, D, and E. Hopefully the programming is going along fine and it's almost done, hopefully. So I would have gone over each of these briefly in class live this week or next. So let me do it recorded, and you can watch a couple times if you need. I mean, it's all here, but you do need an introduction to each of them. So I'll do one video for each. How about? So you know what you've done already, right? Planning and more planning, right? So now, these two parts are part of the design process, right? Along with programming. Development and functionality and extensibility, these two, C and D, are really more of an IB, computer science, IA thing for grading. Okay, evaluation comes back into the design cycle, but these two are not necessarily part of the design cycle. They are showing me and showing the moderator that you've got the grade that I'm going to give you, that you've got the good grade that I'm going to give you. Okay, this is you defending what you did in developing, and this is you showing that it works to one degree or another. All right, so maybe just a little bit more on each of these three before I do development. Working backward, like I said before, evaluation, when everything else is done, you can just sit down and do that in an hour or whatever, right? It's not that big of a deal if you've got everything else done. So don't worry so much about that. Working backwards to the video, again, I probably said this once in class, but it's worthy of repeating again, that it's a 7-minute video. I say that kind of nonchalantly, but if you're good at that sort of thing, then it'll be 7 minutes. The big thing is, does your program work, and to what extent does it work, right? So, meantime, Criterion C Development. This is you, for I'm saying 900 words, going back and describing what you did. Now, there are other things that you can read through here, and definitely do read through the IB description, but we can go straight to the 12 marks. This is 12 out of 35 marks. This is the big one, right? This is the one where to get your 9 through 12, these are all very similar, but I'll read it. The use of techniques demonstrates a high level of complexity and ingenuity in addressing a scenario identified in Criterion A. So you've done it. You've taken that scenario, which was the hardest part of the whole process, getting a scenario, and you've addressed it in a fairly high level and fairly ingenious, as much as you can do for a school project degree. Now, keep in mind that standard levels high level is different than higher levels high level. So, don't worry too much if you don't see your database, your basic database in standard level as being, high level and ingenious. Well, it's not. It's still pretty darn cool, and there aren't many people walking around the campus around the world that can do what you've done. So the problem is, and I won't go on and on about this, the little bit of a problem is, though, that it is the same rubric for both standard level and higher level. So generally, if standard level were doing what they were expected, according to this, they'd have to be getting a little bit lower grade than the higher level. Okay, and that is generally the way that it goes, is that the standard levels generally will get a little bit lower than the higher levels. And it's just a quirk of the way that this works. There's only one rubric for both. And then also, you're describing and defending in these 900 words the fact that the techniques you chose were adequate for the task, and you have explained how they are used. And all sources are identified. That's when you're using other people's work, other people's classes, libraries. You would have hopefully commented that in your code, but you'll also mention it here. All right, this is saying 500 to 1,000 words of extended writing. This is the bulk of your, of your write-up. Okay, you are, one last time, you are describing what you have, past tense, done. Okay, so that you can get a good grade, so that you can be graded appropriately. So how are you going to do that? This is all you're given from the IB. How are you going to do that? You're going to read through and do as much of my advice as you can. And there's a lot. I've written probably, it'd be interesting to know, I've probably written close to 900 words just describing what you should do. So go for it. I'm not going to read through all this right now, particularly that squawking bird in the background, but read through it. It's going to take you 10 minutes, 15 minutes to read through what I'm suggesting that you do, and do as much of it. This is a guideline, right? You can look at the IB example, you can look at the IB requirements as we just did, or you can do this exactly, write exactly what I've got here, copy and paste this and change it to be for yours. You can put what and why. You can put as a third subsection of this Criterion C structure of the program, and you can bold it and you can make exactly that font. You can absolutely, if you wish, follow this to the letter, by the book. Go for it. And I would be perfectly happy to see 1 through 7, and I'd be perfectly happy to see the titles as they are, and again, the why and the what's and whatever. I'd love to see that. But I'd love just as much to not see that. I'd love to see you taking your own tack on this, your own way of, in 900 words, communicating to me and to the moderator what you've done, how you did it, why you did it. But back then to a perusal of the way I'm suggesting, a short introductory sentence or two, just description, and pretty well everybody's going to be the same because pretty well everybody used NetBeans, pretty well everybody used the graphic user interface, but you did, right? And so go ahead and do a short introduction to what you did over the past couple of months in terms of building this program. Definitely make some reference to the techniques that you used. This used to be actually a requirement, and the 2 previous versions of the IA, where you had to come up with 10 of the 15 that were listed. And so it's a little bit of a follow-on from that past one. You don't have to do it, but I would suggest. And I would suggest that most of you can take these and, okay, copy and paste them. And I bet that most of you have most of these that are used, but certainly it'd be nice if there's a little bit of variety there that I saw passed in, and certainly there will be some things here that are not listed. Sorry, there are some things that you did that are not listed here. It'll take a little bit of time, but that's a pretty good start, just looking at that list. Then you talk about the structure of your program, and this is where you talk about classes. If you just look through this section, the one word that jumps out at you again and again and again is OOP. OOP. OOP, OOP, OOP. So talk about OOP. Talk about, read through this, but talk about the fact that you do have a class structure, which is an object-oriented programming class structure. You've decomposed your big problem into smaller problems. You've got specialized classes that do sorting and searching or work with a GUI, etc., etc. So describe it with a what. And then get your head back into why we do object-oriented programming. Read through this. Take a look at some of the other kids' explanations. But this is you saying that for the structure of my program, I chose to use OOP. Well, of course you chose to do OOP because that was our option. And most people would choose to do OOP, but you did it for the first time in a big program. You did OOP. Why did you do OOP? You did OOP because of abstraction. You did OOP because of easier debugging through abstraction. You did OOP because it has encapsulation and protects the attributes of the classes that you're making instances of, and all that sort of stuff that if you went back to the object-oriented programming option, both standard and higher level, there's a whole bunch of stuff that's cool about OOP, and that's basically what needs to shine through here, is A, that you used it, B, that you know what OOP is, and C, maybe that the biggest point that you know why you used it and why we should use it. And it wouldn't hurt you if you wanted to do a really, really good job at this. It wouldn't hurt you at all to go back and take a look at the assessment statements that relate to why we choose to do OOP as our approach to programming. So don't get my 3 and my 4 confused. This is the structure of the program in terms of the object-oriented programming class structure of it. Then we get into the data structures. Data structures are not the class structures. By the data structures we mean, well, this is what we mean. That's what we mean, okay? You probably didn't use trees. You might have used files. A bunch of you used files. Files would count here as well. I'm not even sure that it's written anywhere here. But basically, again, most of you will have similar write-ups here that you used arrays or you used lists. And if you used lists, if you used queues or stacks, then you can talk about them as well. So that's basically it. By data structures, we're not talking about primitives. We're not talking about booleans and ints and so on. We're talking about structures. And the structures that you learned in this course and that you use probably in your IA are those. And again, possibly a tree, possibly linked list as a queue, possibly as a stack, and what else? Files. You might have saved to files and opened from files. So you talk about those that you've used. It should be for some of you, it's just going to be, I used arrays. Okay, you used arrays. Give some examples. And talk about why. Why did you use arrays? And I've had several conversations in the past number of days about whether or not you should be using array list or array for whatever particular given situation, and we've had a discussion, and you've defended your choice, and maybe I've questioned it, and maybe I haven't. But that's the sort of stuff you need to talk about here. Again, this is you've done a program, and people have sold these before. This is the real thing. People get paid a whole lot of money for doing what you've done with this IA. Now you're trying to get your grade, and so you're showing this is a school project that you have learned about data structures and the advantages of dynamic versus static versus queues versus trees, etc., etc., etc. So you talk about what you've learned in the course and as it is reflected in what you've done in your IA. Then this one's maybe a little bit more potentially involved. And arguably, it's the one that most defends you getting a, say, a 9 or a 10 or 11 or a 12 out of 12. And for a lot of you, you're not going to have anything all that schmancy. Okay, you're read through this, but you're simply, quote unquote, going to discuss how you built a database, which again is not trivial, and it's really quite a thing. And you did it, and lots of kids have done it before, and other kids have struggled. So good for you, right? Talk about it. Talk about your database, the basic functioning of it, and that's great. But for those of you, and I've certainly seen a few, that have, I'm going to use that word again, schmancier type stuff, this is where you show it off. This is where you talk about it. So read through this. There's a lot of stuff to digest, but basically what I'm suggesting that you do is put your pseudocode. And some of you have pseudocode. You just copy and paste it from your program. You know, you did the algorithm in commented text beforehand, and then you followed it. So just take that out and put it here. Saying refer to the sample. This is very different than what you're going to do, except for right. Okay, there you go. So that's basically it. And again, his data structures are different than our data structures and so on. But in terms of algorithms, that's the big thing. And you can do them as very close to Java. You can do them as very close to English. You can do them any way you want, right? Pseudocode is pseudocode. But taking the 1 or 2 or 3 more sophisticated parts of your program and talking about it, why it works, how it's cool, and listing the pseudocode. And you know, there's not so much of a why for this. We're not talking about the choice of data types here or the use of object-oriented programming. We're basically showing. You're basically showing off. In fact, like I said before, your main cool algorithms. So read through. And by the way, I see there's screenshot potential. Definitely zoom in on each of those, because you don't want to just write 900 words. What you would much rather, like we saw over here, was something with a lot of different tables, maybe, you know, a little bit of actual code there, some bullet points, some numbers, some pictures. The more pictographical, I'm going to use that as a word, you can make this, the better. You have a tendency, I think, at this stage in your academic careers to just focus in on wanting to write words, lots of words, lots of words, lots of words. But the more diagrams, and look at me too, right? But the more diagrams or whatever you can add, it really, really does help the communication of what you're trying to get across. So to finish off that, then this big one about main algorithms, go ahead. Maybe take a screenshot of the actual code and reduce its size, or whatever you think. Then I'm definitely saying that you should talk about GUI a little bit. And again, all of you, the what is the same and the why is the same. So read through this, read through a couple of the ones from the former years, and don't just completely take their ideas, but talk about why the GUI is a great choice, why it worked for you. And finally, the software tools used again, everybody's going to be basically the same unless you used something like for Java on your graphical or any Excel or anything else that along your path to doing this, you used it, you can mention it there. You know, you probably don't even know what those are, but and just quickly what they are is for getting class diagrams at the end, but we might actually use either of those when we all get back to school as a final wrap-up to put your final class diagrams, blah, 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 blah. I didn't even need to mention that. All you need to do is talk about NetBeans pretty quickly and maybe a screenshot or two. All right? So keep in mind, and read through all of this, keep in mind that you got C and D and E, that E is easy. D I'll talk about in another video I'll do tonight as well, and it can be easy. This is the one, right? This is the last kind of big sit down and work away at this, read what you're supposed to do, look at some past examples, and do a good job. But I'd like to say and think that it is straightforward. It's just a matter of time. And time is the one thing that has evaded people over the past couple of years. And here you are at home, quarantined practically, so hopefully time's not going to be the factor. All right, that was probably a bit much, but there you go.